In the previous video, you should have understood that we can use arrows to represent things called vectors. If you don't remember this, it may be a good time to pause this video and go and watch the other video that will be linked down below, called Vectors and Scalars. So because we know force is a vector, this means we can represent forces acting on an object by arrows. If there is more than one force acting on an object, we simply just draw more than one arrow. And every arrow simply shows us the direction and magnitude of that single force. So we'll get something that looks like this. Multiple arrows acting on an object to represent the multiple forces acting on that object. The force that we get resulting from every single force acting on an object is the resulting force on that object. The overall force that the object feels due to multiple forces that act upon the object. We call this the resultant force. We are now going to look at a few examples of different forces acting on an object that we can draw as arrows. We will then resolve these arrows, or forces, to find our resultant force. In example A, we can see that we have a 50 Newton force to the left, a 10 Newton force upwards, a 50 Newton force to the right, and a 100 Newton force downwards. So if we're going to resolve this horizontally, we're only going to be looking at the horizontal components. I'm going to denote this resolving horizontally as R brackets horizontal, so that we can keep track of what we're doing. To look at the horizontal components means to only look at the components of force, so the forces acting along the horizontal direction. And I've shown this with the green circle. We only have the 50 newtons to the left and to the right acting horizontally. So they're our horizontal components. It's important to understand here that we have 50 newtons of force going to the left on this object and 50 newtons of force pushing to the right on this object. So these forces are in fact balanced, which means because they are balanced, there's a total of 0 newtons of force acting overall. So our resultant force is actually 0 newtons. We found there is a total of 0 newtons for our resultant force horizontally, which means the object will not move in either direction, as the forces horizontally are balanced. So now let's look at the vertical components of force, which you can see where I've circled the forces in blue. We have 10 newtons acting upwards and 100 newtons acting downwards. The way that we can find the resultant force is first by using a bit of intuition. So we can see the largest force is acting downwards and the smaller force is acting upwards. The resultant force will be acting downwards. Now we just need to find what this number is. So to do this, we take the larger force of 100 newtons and we minus from it the smaller force of 10 newtons. And this gives us an overall force of 90 newtons downwards. We have found out our resultant force vertically is 90 newtons downwards. Let's look at example B. Here we have the blue person pulling to the left on the rope and the red person pulling to the right on the rope. The blue person pulls with a force of 10 newtons. The red person pulls with a force of 8.7 newtons. Again, using our intuition, we know that 10 newtons is larger than 8.7 newtons. This means we know our horizontal resultant force, because in this diagram there are no forces acting vertically, our horizontal resultant force will overall be to the left, because the force pulling to the left is larger than the force pulling to the right. To find this then, we simply minus the smaller force from the larger force. So 10 newtons to the left minus the 8.7 newtons that acts to the right, and this gives us a value of 1.3 newtons overall to the left. To summarise this video, I would like you to remember these 3 key points. If we have more than one force acting on an object, we can always represent these forces with a resultant force, and that's something we just have to figure out. Secondly, we can always represent forces by arrows, with the length of the arrow representing the magnitude, so size of the force, and the direction of the arrow representing the direction of the force. And thirdly, it is always important to draw a diagram to make sure you understand what is going on.